Hello, everybody. It's great to be here one more time today. My name is Gary Fowler. I'm the CEO, president, founder of GSD Get Shit Done Venture Studios, premier quantum venture studio located in the heart of Silicon Valley. I'm a 17-time serial entrepreneur with several unicorns under the belt. I was on the original management team of Click Software, which was sold to Salesforce for $1.35 billion. And also Eva.ai, an AI HR tech company that co-founded with Dr. David Yang. We believe at GSD that intellectual capacity is evenly spread, but opportunities are not. And today on Top Global Startups, I have an incredible guest today. We are going to be talking about diving into one of the most ambitious frontiers in technology, hardware Deeptech at the intersection of AI, advanced physics, and industrial transformation. I'm excited to welcome Andi Hektor, the CEO and co-founder of mu-ray.tech. Andi's journey is extraordinary, spanning 2 decades of elite scientific research, including work at CERN, where he contributed to the discovery of the Higgs boson, to now building real-world industrial systems that can literally see inside matter. With mu-ray.tech, Andi is redefining 3D imaging using AI-driven artificial muon sources, unlocking breakthroughs in non-destructive testing, advanced manufacturing, aerospace, defense, and even medical imaging. Today, we're going to explore what it really takes to build hardware deep tech in the AI era, why Europe is uniquely positioned to lead the next industrial wave, and how frontier physics become scalable, investable, and transformative. And with that, I'd like to welcome him to our show.
Gary,
hi, Andi.
Hi, Gary. Thank you for having me. It's a really sweet introduction. Thank you.
Yeah. So, Andi, you started your career exploring the deepest mysteries of the universe. What was the moment you realized this knowledge could turn into industrial scale technology?
Oh, that's a good question. When I started as particle physicist, I started my PhD. I was coupled to the big experiments at CERN. It's a big particle physics center, huge tunnels underground, huge building size detectors, and of course I was very fascinated about that. But I also saw very quickly that how deep is connection between this leading scientific technology and the industry. It's really coupled and the connection. It's very complex. In one way, the scientists asking big companies to provide some very specific technology, but on the other hand, these companies are learning a lot to providing this technology. So I would say it's a big, I don't know, cooking place. You put the different things together, and then you cook something very wonderful out. And of course, very talented people also around. So it's a nice hotspot. And of course, you can see this MIT, you can see this California, and so on. So I would say that I learned very early. But I spent more or less 20 years in particle physics, and then I had kind of a middle-age crisis 6 years ago, and I decided to jump to my first, let's say, big startup company called G-Scan. And then I realized that, of course, I was interested. I was kind of prepared, as I already had some colleagues jumping to the different startup companies. But still, I have to say that it wasn't easy learning curve.
Yeah, no, it's never easy, right? You go down through, and then you can't go to. I have Harvard MBAs, Stanford MBAs, MIT MBAs, and PhDs that have come into GSD, and in fact, Harvard's started the first MBA, but it was teach managers how to manage. Being an entrepreneur and taking risk is a whole different thing. In fact, sometimes it's managing risk sometimes is not a big option when you're doing a startup. You got to have a leap of faith and move forward. And sometimes we forget about that. So, for listeners who aren't physicists, what is a muon beam imaging, and why is it a breakthrough compared to traditional imaging methods?
Yeah, it's my favorite question, to be honest. And of course, everyone knows X-ray. X-ray, if you go to the doctor, they use X-ray a lot. You can do, I don't know, image for your lung. You can dentist, they are using this. Probably in everyday life, you don't know so much about industrial side of the X-ray, as you have a lot of X-ray systems also in this industry, starting from the, I don't know, chip quality assessment, starting from the, I don't know, even if you a more expensive type of meat, they use X-ray to really see what maybe there is something accidental inside. And of course, you need, security. You need X-rays to see, is it something illegal, something nasty in somewhere hidden. So X-ray is widely used, but X-ray has certain troubles, and I always like to highlight three main troubles. The first one is X-ray can't penetrate very deep. For example, if you have, let's say, 10 centimeter of steel, I'm sorry, I'm using centimeters. In this case, X-ray can't penetrate, and and in the case of, for example, illegal smugglers, they know how to hide things. They put some, I don't know, steel, rocks, something around the let's say illegal thing, and then it's hidden. X-ray can't see. And the same trouble is in industry. For example, very I don't know, visual example, probably nuclear reactor, something huge. You can't open this if it's running. You have, I know, chemical distillation system. You can't open this if it's running, but you would like to know what is going inside. It's very hot. It's dangerous. You can't put sensors inside. You're melting, for example, metal. You can't put the sensors inside. In this case, X-ray can't help. It's too massive. So this is the first thing. Then the second one is a question about the chemical sensitivity. X-ray is very good to show the density difference, but it's not so good to show the chemical difference. For example, if the density is more the same, then it's very difficult to see difference. Just one random example from the industry. You have battery, you have some semi-liquid material inside the battery, and it's very difficult to see the chemical difference in the case of these materials. But you like to see this. You like to do the quality control, for example, for the battery in the car battery industry. You have 1,000 or even million batteries going out, and you need to do the quality control. This is the second one, and the third is safety. Everyone knows that X-ray is dangerous, so you can't use this everywhere. It's very limited. You need very certain rules. You have to follow the rules. You need to do the paperwork. You need certificates, and so on. So now I can explain a bit my topic, muons, or muon radiation, or muon rays, if you like. This is particles. They are charged particles, a bit like electrons, if you know electrons, but they are very penetrative. So they can really pass tens of meters of material. If you go underground, then you can even see, if you go 100 deep, even then you can see these particles. So they are really penetrative. They can also show the chemical difference, and as I mentioned, safety is also very important. To get same level, same resolution image, you need probably 10, even maybe 100 times less radiation dose to build same level image. So these are three big aspects. But of course, there is also downside. The system itself to generate muons was historically very expensive. Historically you needed huge particle accelerator, cost hundreds of millions, even billions, to generate. So it wasn't commercially viable. But what happened 10 years ago was that there was new technology coming in. It's called laser plasma accelerators. It's more or less tabled up, let's say, room size system using very powerful lasers. And using this system, you can really produce muon radiation, and that's the beginning of the story, let's say.
So I have a multi-agent large language model that listens to the conversation, and 14 language models is one, and she has some questions for you. She's like my grandmother. She has empathy, compassion. I built the model, and one of the things she said, it's interesting. What were the key physics constraints you had to overcome to move from passive cosmic muon sensing to an active, commercially viable muon beam?
This is very right question and very good question. Yeah, historically, I think the first time physicists thought about using the cosmic radiation, cosmic muons. Also, it's a part of the natural radiation. It's around us. So every minute, more than 1,000 muons are passing human body. So it's possible to use this. There are nowadays, I believe, 20 companies, startups around the world doing this. But there is one big trouble in the case of natural muons. They are nice, they are safe, we are living inside, but to build reasonable image out of these muons, it takes time. So, for example, my former company G-Scan, if you need to, for example, we are assessing the bridges. What is the condition of the bridge? Is it collapsing or is it safe? So in this case, you need, let's say, 1 week or even weeks to really see what is going on inside the reinforced concrete. So it takes time. In the case of bridge, it's fine. Bridge, they don't run around. They are not like humans, so it's possible to use radiation. But for example, in the case of medical applications, you don't like to be kind of in certain machine in 1 week, so it's impossible to use this. And also in industry, time to time, you need to do something very quickly. For example, quality control.
Mm-hmm.
You have production line, something is going out very quickly. You need to do this very quickly, and yeah, in this case, natural radiation doesn't work. So you need artificial source.
You know, she's asked this question: which parameters most directly determine image resolution in a commercial deployment? Muon energy, flux density, detector geometry, or reconstruction algorithms?
All these facts are important, but I would say that to really start to build this technology, of course, I already mentioned laser plasma accelerators. This is I would say, one triggering technology. AI, definitely. The data we are collecting is very noisy, especially in the case of natural radiation. It's very, very noisy data. So I would say that without modern machine learning AI, it's more or less impossible to do this. And I remember our first raw data. It was terrible. It was nothing was visible. Using machine learning, we improved the model, and now it's amazing. I have to say that later I can show it to you, but it's amazing what we can see inside. So I would say without AI, it's a second important component, and of course sensor technology, as we are using kind of other special advanced muon detectors. It's the detector technology. So it wasn't very big technological jump, but what jump was in the pricing. The input components, they were getting much cheaper, let's say 10 years ago. And that was the reason why this breakthrough was coming. So yeah, I would say 3 key components.
And she's asking, and she says, what part surprised you most when you left the lab? Beam physics, systems engineering, or customer expectations?
Again, tough questions. I prepare a few human-centric. Yeah, I would say that clients are always kind of tough and also exciting, as you have to learn. When I started to be the Deeptech founder, I was to be honest, I was a bit annoyed by different clients, as they have very different attitudes, very different styles. I don't know, some of them are very aggressive. But I have to say that later I somehow learned to enjoy this. It's a bit like intellectual game also, you can think.
You know, why is the right time? Why is now the right time for hardware deep tech to accelerate alongside AI?
I would say that, yeah, it's also a very complex question that at least it's my belief, and I can see different signs about that around. As you know, AI is definitely speeding up the software development. No doubt there. What is going to happen in hardware is something similar. It's more complex, as part of the story is, for example, 3D printing. As historically, as I know, it was if you need to do some mechanical thing, very complex, then you had to find the correct technology, the company providing this. Then you probably need to wait, I don't know, 3 or 4 months to get this physical detail back from this company. what you can do now, you just use 3D printer. So it's some sense, yeah. And this is the story of, let's say, physical production is getting more flexible, quicker. But also to design these type of things, you can use AI. So I'm kind of surprising that, of course, you know, if you write the software, if you're a software developer, then AI is very helpful to especially if you start writing something. And it's slightly similar in the case of, for example, if you start to design physical thing, in the beginning it's very helpful. Probably you know the CAD software, how to build the three-dimensional models. It's a very powerful tool to use AI in this context. And yeah, of course, this is the, let's say, development and R&D side. But also, what I was so surprised in the summer when I started to build up my own company, new company, spin-out company. Historically, you know, you need to do a lot of market research. It was typically you needed special young advisor type of for that, or assistant type of person for that. Nowadays you don't need. It's so much more effective. You can yesterday at weekend you just sit behind your computer and you just start to do something, and you get so much new, not super high quality information, but high quality information. As still the human, you need human interface also. But I would say that to get the, let's say, kind of 1 and 2 first steps, AI is so powerful.
You know, I built a cancer vaccine last year. My dog had stage 4 kidney disease, and I ran my model. And at a molecular level, we built a cancer vaccine for my dog using a lab called Ardent Animal Health, located down in Kentucky. And my dog went in complete remission of stage 4 cancer. And then I told you about my thing with the stem cells, but I used the model, I put it on myself, and I had stage 3 kidney disease, and I had 50 million mesenchymal stem cells undifferentiated from an umbilical cord done by the top doctor over in Thailand. And my stage 3 kidney disease was gone in a matter of a day, actually. And then everything else started changing. And I used the model. I ran the same model that's actually going down through. She's got so many questions for you. It's unbelievable, actually. She's curious. She's listening to the conversation. Bye-bye. These tools give us superpowers, Andi, that we've never had before. She said one thing, you know, she told me to ask you this. This is kind of she said people are familiar with particle beam weapons, and they may not understand, you know, how you're using the particle beam. How do you overcome those, or educate in those type of situations?
As you know, if you say the word radioactivity, then everyone starts to be a bit afraid, or race, or this type of wording, especially, as you know, also social attitude is a bit changing nowadays. As nuclear energy was something very bad, now it's getting more positive again, and so on. So it's always a bit fluctuating, but still, it's a dangerous thing. X-ray, for example, is a dangerous thing. You
particle beam, but your particle beams, what she said to me is they go through all the time, buildings and everything all the time. They're cosmic, right?
Yeah, the cosmic ones. Yeah, if you have a small dose of radiation, it's normal. We are living inside. We used to. We are, let's say, living organisms, living billions of years in the same conditions. So we are used to. We tolerate this. But also, what is I always like to say that also they are very relevant. As you know, they create tiny mutations, and these mutations are typically dangerous. But without these mutations, you have no evolution. So I would say in this way you can say that they are also helpful for living organisms. So I would say that definitely they are dangerous if they are too powerful. And this is another story of our technology that in principle, if you produce very powerful muon beam, you can start to disturb, not killing people, but you can disturb the electronics. So it's also one idea to protect, let's say, you can shoot down the rockets and planes and so on using this technology. It just disturbs the electronics very, very strongly. But in this case, you need extremely powerful beam. I would say this definitely not the first thing to do if you don't have, I don't know, if you have billions, then yes, but we don't have yet.
No, it's really interesting. You know, I see it. I have Cerebru's one of our companies that's in Denmark. So, and they have they're growing like crazy actually. And you know, these imaging, it's everything's connected together, Andy. Everything's connected as one because we can't go down through and make decisions unless we have the data. What you're giving people is data. The problem we have is infobesity for everything, whether it's defense technology, whatever that is. We've got to go down through and use that data to be able to make better decisions. And we need the superpowers of the AI to help us. And then everything becomes one, right? So the decisions from a health tech is of imaging, that goes over to the doctor. You find the best doctor. Everything's optimized, and it goes to a different level. It's amazing, actually. What you're doing is going to happen. The key is how do you get your Ferrari out of the garage, or Porsche out of the garage, so people can see it. And it's not just taking it down the and driving it down the Autobahn or taking it down some Alpine road. It's about winning Formula One. And we forget sometimes, right? It's crazy. We forget. And I mean, what you're doing is going to change everything, because when you can see through things, you can make better decisions, and including, whatever it is, whether it's defense, whether it's nuclear and chemical industries, whatever it is, medical imaging, each one of them needs to know more faster.
Yeah, that's it's very good. You mentioned the Formula One. It's a very good example, as we have some contacts in this world, and it's as you know, it's very innovative. It's competition. So and you can think about the engines. If you really need to model this engine, you need very good snapshots from the reality to build your virtual model, and that's one reason, or one place our technology can provide a lot of value, extra value, as you can really do high quality image from the engine. You can put your virtual model, and in this case you can do, let's start to think about the more industrial things like gas turbines, for example. You can build up the predictive model, so you don't need to stop your engine so frequently, as you have already virtual model. Time to time you need to check this against the reality. So using again our imaging technology,
you can go down through. No, I love it for everything, right? You know, we have 180 companies inside my portfolio today, and a lot of them are med tech companies, and they're changing the world. And this is, you know, using the AI to be able to do it. But you know, the third part is getting it out to the market. It's getting that Ferrari to win Formula One, right? And the reason I said that, I had cigars with Emerson Fittipaldi, and he won Formula One actually. So yeah, had a good time with him. Anyhow, how important is non-destructive testing as manufacturing becomes more complex and mission critical?
Yeah, it's getting more and more relevant, and so there are different reasons. I can't explain everything, but one very crucial aspect is that 3D printing. If you think about the 3D printing, historically you had a lot of pipes, you had plates, you had cubics, you had certain shapes, and you put everything together. And in principle, also it was possible to somehow demolish the system and to see what is going on inside. But if you have, for example, you have a rocket engine, you print this, you have a lot of tiny cooling channels inside this engine, the huge metallic part somewhere in the middle of this, and you have thousands of these. And now the question is, you can't open this. It's impossible. You can't use X-ray if it's very massive. If it's a bit less massive, you can use X-ray, but it takes a lot of time as the scanning time is so long. So this is for
how long is the scanning time, Andy? Like, how's it compare? I mean, you're like, how much faster? So if a task takes 20 minutes doing X-ray, how long does it take using Muon?
Yeah, we need kind of, let's say, simple calculations or modeling. Again, you can use the virtual modeling in this case. For example, there are certain cases they need, let's say, few days scanning time to get sub-millimeter level images, 3D dimensional images out. And in our case, we really let's say in the first generation system, probably 15 minutes. But there are no limit in the sense that I believe that later, maybe second generation, at least my let's say target is 2 minutes.
Wow,
So, and
that's and how much time, how much trouble, and how much liability does it reduce, right? Because you,
yeah, and it's I can give very simple example about that. Of course, SpaceX rockets, they are they they are reusable, but between the cycles, launches, you need to do the non-destructive testing. You really, it's mandatory to see is there some small cracks inside or something, and it takes certain time period, let's say 2 weeks, maybe more. I don't know exactly how long it is, and big fraction of this time is going for non-destructive testing using the X-ray systems. So and also X-rays are dangerous, so you need a lot of safety related procedures you have to follow. And I would say that if you can use our system, then you can do this in the same site. They can't work inside the beam, but they can be close by. It's quicker, so now you can start to calculate how if you can do more cycles using your reusable rocket, then how much money you can save. So this is I would say very kind of quick example what you can do using non-destructive testing. Of course, it's just one example, very let's say visual, but in everyday industry, it's a full of this type of examples. Starting for example, battery system, car batteries, you need to do the quality control. If there's something broken, you can't open these systems very easily. So you would like to do kind of
yeah, I love that. No, those are, um, but it's everywhere, right? So whether it's manufacturing, whatever it is again, it's speed, and then not only speed, but how good is it? How much better are you than typical X-rays? In terms of identification, it's got orders of magnitude, right?
Yeah. I think this is very important, and there are also some certain cases you can't use X-ray. For example, if a nuclear reactor, they just can't pass so large object. So, for example, using the natural radiation, natural muons, we did very nice project. There are two kind of semi-conserved reactors in my home country in Estonia. They are from Soviet times, and there wasn't any. Okay, they had some documentation, but it was really poor. And of course, there was a lot of worries about what is inside and what is going on there. And there was no technology to really see. They are filled, Soviet army, they filled this with concrete, and nobody knows what is inside, and you
Really?
can't open these. Yeah, it was kind of old style conservation.
One of my favorites down in Riga
Yeah.
for a while, and I used to go over to Estonia and Lithuania. I spent time, and that's interesting. But there's all kinds of different things that you could look at, right? Using the technology.
Yeah. I would say nuclear industry is full of this type of hidden, let's say, dangerous things. Of course, probably have seen all these barrels. They let's say in 50s, 60s, the culture was slightly different, the safety culture. So they filled these containers, they filled this with concrete, and nobody knows what is exactly inside. So to really know, you need
People,
technology.
right?
Yeah.
That's
So
amazing.
and there are tens of thousands this type of containers around the world. So I would say this is probably one business lines for future. But I would say it's an endless world. The imaging world is really huge, and probably the biggest one is probably still medicine, radiology. As typically humans, we would like to know a lot about our body, what is going on inside, even if we are not.
Right? We want to. My wife just had been diagnosed with breast cancer, with stage 2A, triple negative, and it's all about finding it. We found it early, right? So, but having the technologies to find it early before it's a problem.
Yeah. This is one example. I let's say it's my long-term vision to use this technology. Is that breast cancer is one example, but many cancer forms, they tend to collect different. For example, if you breast cancer, this tumor start to collect calcium. Some other cancer forms, they start to collect iron, And this is very visible for muon imaging.
Boy,
As,
that's fantastic. I love what you're doing, Andy. You got to get the Ferrari out of the garage to win the race.
yeah, definitely.
We're-
But also, it's a nice part of this technology is that it's complex, expensive technology still, but all the sub technologies are kind of, I can't say ready. For example, let's say muon tomography using the natural radiation. It's TRL 8, 9 level technology already. Laser plasma accelerators, let's say TRL 4, 5. So our task is more or less integration of these, let's say, viable technologies we need to put together. I always like to say that integration sounds very easy, but it's not easy. But I'm not. Someone asked just today that how much you are worried about the technology. Are you worried more about the technology side, technology risks, or business risks? So I said I don't worry about the technology. The technology is already there. We just need to integrate its engineering task to make this cheap enough. So it's not, there are not question that is it working or not. Business is different story. You can do mistakes. You can pick up the wrong business vertical, too slow, too complex to enter, just wrong in any other reasons, and you are spoiled. So I would say that I'm much more worried about this side at the moment.
Now, I understand that. Having built all these companies, we work with thousands of them on the GSD side. Listen, we're coming at the top of the show. If you want to spend a few minutes afterwards, we can talk. I really appreciate taking your time out of your busy schedule. You have an incredible technology that'll make the world a better place in all kinds of different ways. So, closing thoughts, and how do people get hold of you?
Oh yeah, I'm now so excited already talking about the technology, but definitely I would like to, if you have this type of trouble that you really like to see, you have a huge object, you would like to see what is inside, so we can help. Especially if you have rocket engine or something like that, very wonderful, and then we are really happy to collaborate.
No, that's great. And how do people get a hold of you? What's the best way? LinkedIn or email?
Yeah, LinkedIn is nowadays natural way to, definitely web page. We have web page, so it's also possible to find us. Yeah, but LinkedIn is de facto standard.
That's fantastic. All right. Well, thanks for taking time out of your busy schedule. And thanks to all my viewers for joining one more time. GSD presents Top Global Startups. My name is Gary Fowler, and I'm your host. Stay happy, stay safe, and stay healthy. We'll be back again soon with another exciting edition. Thank you, Andy, and thank you, everyone.